These are the notes for Introduction to Molecules. And so what you are looking at right now is kind of review. These are atomic models, and we learned before that atoms are made of protons, which we made red, and neutrons, which are the white ones, and then the electrons, which are the blue ones, right? And so that is what atoms are made of. They're made of protons, neutrons, and electrons. Atoms are the smallest unit of an element, right? So if you have a bunch of carbons put together, that is a specific atom, that's an element. Oxygen, these are all three atoms, but they're different elements. Okay, so moving forward, we are going to stop looking at models of atoms like this and instead replace them with things like this. So the black model, the black ball, is a carbon atom. The red ball represents an oxygen atom, and the white one represents a hydrogen atom. And when we look at these, you'll notice like this only has two holes. That's because it can only make two bonds with other atoms. And the hydrogen only has one, it can only bond with one other atom. And then carbon has four, and so it can bond with four other atoms. Okay, so just keep that in mind whenever we continue on to the rest of this lesson. So, what is a molecule, right? We've heard this term in places, molecule. Some students yesterday thought that maybe a molecule was the things that make up atoms. But that is not true. These things that make up atoms are the subatomic particles, the protons, neutrons, and electrons. And so a proton is smaller than an atom because that's what makes up an atom, right? And electrons and neutrons, they're smaller than atoms. But molecules are actually made when atoms connect together. So two or more atoms bonded together. And we'll look at some examples. And so here's the carbon atom, and here is a hydrogen atom, and if they can stick together, now that would be a molecule, right? And so it could just be two things stuck together, or it could be billions of atoms stuck together. They're giant, huge molecules. The chemical formula is like the name of the molecule, and it is the letters, which represent the elements, and numbers that tell what atoms are in a molecule. Okay, so I'm going to use two different highlighters here. There's two different terms that we're going to use that you will need to understand molecules and chemical reactions later, and those two words are subscript and coefficient. Okay, so you might have seen these in math, at least coefficient you probably have. So the subscript is the small number, and that tells how many of that element are in one molecule. Okay, and so all of our subscripts are these right here. So there's 6 carbons, 12 hydrogens, and 6 oxygens. And so that's how you have to read this, is it goes like these. Okay, so over here, there are 2 hydrogens. If there is no number, imagine there's a 1. So there's 1 oxygen in that. Okay? The other thing we need to know is coefficient. And so the coefficient is the big number in front, and that tells us molecules. So for this, so there's no coefficient, so there's 1, right? There's 1 molecule of C6H12O6. But here, there's 2, which tells you that there's actually 2 molecules of water. Okay, so down here, we're going to use the same colors that we used before, and so go and fill that in. Carbon is black, hydrogen is white, and oxygen is red. Okay. And this key goes with these pictures down here. But now I see that there was some more stuff that we needed to fill in. We'll come back to that, actually. So here are 4 common molecules. There are so many, but these are just 4 that I thought we could start with. And so this is a molecule of H2O, which maybe you know as water. And so what does that tell us? There are 2 hydrogens and 1 oxygen. And so the oxygen's in the middle. So it makes 2 bonds, one with 1 hydrogen and another with another hydrogen. And that is a water molecule. Okay, here is a carbon dioxide, which I just told you. So CO2, which is carbon dioxide. And so the middle is the carbon, and oxygens are on the side. Down here, this is hydrogen gas, which is H2. And we don't need to color it because hydrogen is white. And this big guy, and I actually messed up on this, so there should be one more right here. This is that example from up top, so C6H12O6, and that is glucose, which you might have heard of before. It's sugar. People, especially if there's people with diabetes, they take insulin to regulate their glucose level. It's just sugar. Okay, and so this one's a little complicated. So we're going to start with the carbons, and there's a carbon here, 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 and here. And then the hydrogens, there's one here, 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 so we could double check this. So there's 1, 2, 3, 4, 5, 6 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens, and 1, 2, 3, 4, 5, 6 oxygens. So there's, that's correct, right? This is our chemical formula, and this is the model of the molecule. Okay, so what are these atoms held together by? They're held together by chemical bonds. That's what you call those. So that's what these lines, yeah, I'll show that here in a second. That's what each of these lines are. So between this oxygen and this hydrogen, there's 1 chemical bond. And you can see between this carbon and this oxygen, there are 2 lines. So that means there's actually 2 bonds there. Okay, and so the most common type of bond that we will talk about are called covalent bonds. There are many, there's like 2 other kinds, but I don't think we need to talk about those at this level of science. And what causes covalent bonds? It is made when they share electrons. Right, so if we look back to these atomic models, all right, this carbon, it has, and I think actually that I made the electron shell a little incorrect, but anyways, there are electrons on the outside that it can actually share, and so if this one were to lose an electron, it could share one with this oxygen, and that is what could happen. And so then they would be bonded together. Okay, and so these were our notes. One more thing I probably should mention. Okay, so this coefficient, tells us that there are 2 water molecules. So imagine that there were 2 water molecules. And so if you wanted to know how many hydrogens there are, one molecule has 2, right? But if there's 2 molecules, so one molecule has 2 hydrogen atoms, but if there's 2 molecules, it would be 2 times 2, which is 4. So this has 4 hydrogens, right? And there's only 1 oxygen and 1 molecule of water, but when you have the 2 in front, it makes it 2. And there are 2 water molecules. Okay, let's say there was a 3 in front of this, right? And so there's 1 carbon and 1 molecule of glucose, but now if we have 3 molecules, we would multiply that, and that tells us that there are 18 carbons. There are 12, when you multiply that by 3, that is 36 hydrogens. Oops. And then there's 6 oxygens in one molecule, but if there's 3 molecules, it'd be 3 times 6, which is 18 oxygens. And there are 3 molecules of glucose. Okay, so I did that because on the back of this paper there are some practice problems that go along with the lesson. So go ahead and try and get that done, and if you do it digitally, you can share it with me and I can check to see how you're doing. If you have any questions, let me know.